Hey everyone, I hope you're all staying happy and well, and welcome to the channel. In this video, we'll be learning how to deploy a machine learning model to Heroku by building a Flask API that includes a Swagger UI. We also have a pre-trained spam classifier model that we trained in a previous video, so if you're interested in learning about that, feel free to check out the link in the description below. So hopefully you'll find this video interesting, and of course, if you do and you want to see more machine learning videos, please do consider hitting the like and subscribe button down below, as it really helps with the channel an incredible amount. Now, before we begin, we'll just quickly demo what we'll be building towards today. And so as you can see on my screen here, we have the Swagger UI. And basically, if you haven't worked with this before, it's like a user interface provided for you by the Open API specification that allows you to basically have this user interface to send requests and interact with and pretty much list all the endpoints that are available for your API. And so the end result of this is basically a simple endpoint, a post endpoint called predict. And basically, as it says here, it'll generate spam or ham predictions based on the input comments. And so as you can see here, most of this UI is already pre-generated for us. We just have to fill in a few fields, which we'll go over in a second. But so we just take a sample the request body here and we hit send or try it out. It should return an array. Awesome. Yeah, so it returns an array with integers. And basically, each integer will represent whether it was spam or ham, ham being non-spam. So 1 would be spam and 0 would be non-spam. So if I just say, write a new comment here and say something like, this was a great video, and another comment, we just say, oops, we can say test. And we send this, we should get an array of 2 elements. And as you can see here, the first one got predicted as not spam, and the second one got predicted as spam. And yeah, so this is pretty much what we'll be working towards. But for now, let's dive right in. So the first thing that we actually need to do is install the necessary modules. So for this video, I'll be using pipenv, but feel free to use like virtual event env directly. But anyway, I'll be using pipenv, which basically behind the scenes starts a virtual environment for us anyway. So to do so, we'll just start pipenv shell. We'll type that in, and it should launch a virtual environment for us. I've actually already set it up, so it didn't take long. And it also creates a pip file for us, which is great. So the modules that we actually need are as follows. So we can do pipenv install connection is one of the first ones we'll need, and this will help facilitate our building our API and configuring the Swagger UI. We also need pandas, which is a data manipulation framework. We also need scikit-learn, which will handle our machine learning model. And last but not least, we need Gunicorn or Gunicorn, depending how you want to pronounce it. So we'll just give this a second to install, and we'll be back when this is done. So once those are done, I actually realized we forgot one more dependency, and it's a submodule of connection, which got extracted out, I believe. But basically, it's going to be connection in square brackets, Swagger UI. So we're going to go ahead and install that. So just make sure to include that, and we'll be back when this is done. So once those modules are all installed, we can actually go ahead and set up our server. So we're just going to call this file a server.py file, and this is going to be created in the root directory of our project. And essentially, this will be our entry point into the API, and that starts the server as well. So I'm going to go ahead and import our first module that we need, and it's going to be connection. And we're going to construct the connection app, which behind the scenes basically instantiates a Flask application. So we're going to call the constructor connection.app, and we're going to reference the Python special variable, the name variable here as the first argument. And then we're also going to specify a second argument called specification directory. And essentially, this is going to be the directory of which connection will look for our Swagger configuration file. So the next line that we're going to write is we're going to actually link the Swagger configuration file, which we'll create immediately after this. So we're just going to call that swagger.yaml, and this is going to, of course, going to be in the directory specified by the specification directory, which in this case is also the root directory. So yeah, this line essentially links the swagger.yaml file to connection. And we can also actually create just a simple endpoint at the root. I guess like just to say that our endpoint is online. So we can return a quick message saying endpoints are online, I guess. And yeah, simple as that, just so that we can ping it, I guess, later on. And of course, if we wanted to start this application, we can just do if name equals if main, and then we can print a log message, but it's okay. We'll just start the application from here, and we'll be running from port 5000 for local development. And yeah, so once that is done, we're going to hit save, and we can actually now move on to writing the Swagger configuration file. So the Swagger configuration file is basically the bulk of the setup for configuring the Swagger user interface that we saw earlier. That's really useful for interfacing with our API and all its endpoints. Basically, we're just going to create a file in the root directory called swagger.yaml, and there's going to be a couple fields here that we're going to go through. So the first of which is just going to be specifying the Swagger version, and this video will be using OpenAPI specification of 2.0 or Swagger 2.0. And of course, we can also specify some general information about the API. For example, we can include a description. We'll just say this is the Swagger file for the API, and we can also specify a version of the API. Of course, this is probably not the best way to do versioning. I'm just going to do 1.0.0, and we can also include things like a title. We can just call this the API for now. Feel free to name this however you wish as well. Anyway, the next thing that we need to specify is the consumes field, and essentially this will specify the set of MIME types that our API in general will consume or support. And in this case, we're just going to be supporting application JSON, and it's going to be a similar case for what it will produce. And as you probably guessed, it's going to be under produces field. So this is essentially what our application will support in terms of its responses. And yeah. Now the next field that we want to specify is this field called the base path, and essentially this is the base path of all our endpoints. So if you recall earlier in my address bar when we were looking up the Swagger user interface, I had localhost port 5000/API, and that's because I specified the base path as /API. So basically all our endpoints will be available underneath this base path. Feel free to use whatever base path you wish. I'm just going to use /API here because that's the convention I like to follow. Now, because we're using OpenAPI 2.0 or lower, the standard, the Swagger configuration file will only allows us to use this field called definitions. And basically what this is a section where we can specify or define things like schemas in terms of like the response body or request body schemas. But I believe in this OpenAPI 3.0 or Swagger 3.0 and above, it should be a field called components, and underneath that you need to create another field called schemas. But anyway, for this video we'll just be using definitions, and underneath this we can define our own schema variable name, and I'm just going to call this predict request body because this is going to be defining the schema for the request body of this endpoint. And we can also specify a field of what the type of this request body is going to be, and I'm going to be accepting an array and only an array. And basically the items in this array are going to be of type string, and we can also include a simple description. We can just say YouTube comments to classify or singular, sorry, because it's a single comment. And we're also going to include an example, so we can just say sample comment here. And there we go. So that's basically the schema which we'll use in a second. And so now the exciting part is specifying the actual endpoint paths, and this is going to be under a field called paths, and immediately under we can actually specify the endpoint itself, or the variable name, or sorry, the name of the endpoint itself. And in this case it's just going to be predict or /predict, and we're going to specify that as our first field. And then next we want to specify what type of endpoint this is, or essentially what method, HTTP method is going to use. And of course we're going to be using a post request because we'll be sending data to our server for processing. And underneath this we need to specify a field called operation ID, and basically this allows us to specify the path of which our function handler for this endpoint will be located in. And we're going to be creating another file called spam_classifier later. So we're going to name it as such here, and we're going to have another function inside of that called predict. So we're going to do spam_classifier.predict, and that's going to be our path. The next field we want to specify is the set of tags. Of course, a lot of this is just for convention and for filling in the aesthetics and the boilerplate description stuff that we saw on the user interface earlier. So we're just going to keep this in so that we have all the blanks filled in, which we'll see again at the end of the video. And yeah, similarly, I also have a summary and description field pre-written for us already. So I'm just going to use this as well to save us some time instead of from writing it, which we'll see where this appears later on. So the next important field that we want to specify is actually the parameters field, which basically allows to specify or enforce that the user needs to include a request body in the request. Basically, it will use the request body schema that we have defined here. So to do that, we're going to put an element in the array in YAML format, of course, and we're just going to type in body. We're also going to reference body as the name under the name field as well. And we also can include things like a description and just say something like, this is a required array of string comments in the request payload. Awesome. Okay. And of course, because we've said it's going to be required, we should also set the field of required to true. And last but not least, we can include the schema here. And because we've already defined it up here, we can use Swagger's configuration variable called ref, which allows us to reference that. And we can just reference this by proceeding with a hashtag and then slash and then definition slash and then our variable name here. So I'm going to reference that as such. Now the last field that we can specify is the responses field, and essentially this will specify the set of responses, the status codes, and the schemas that are potentially able to be returned. So in this case, we want to have a success response. I'm just going to use status code 200 here, and we can include a simple description and just say this is a success endpoint, or sorry, response. And of course, we also want to specify a response schema. In this case, the response is going to return an object. And under properties, we can specify the fields of this object that it will return. So we're just going to return one field, and this is going to be the predictions field. And of course, this predictions field is going to be an array. If you recall earlier, we kind of demoed this in a bit at the beginning. So yeah, it's going to take an array, and we can also include a description of what's going to be held in this array. I'll save that for later. But we can also, we also have to include the items field whenever we specify an array, and essentially this will basically define what type of items will be stored in this array. And of course, we will be storing integers because they will, it's either going to be a 1 or a 0 to represent spam or non-spam. And we can also include a simple example and just say 1 for an instance of a spam message. And I've already pre-written a quick message for a description, so I'm just going to paste that here. So just saying integer values indicating spam or ham, where 1 equals spam and 0 is non-spam. And yeah, so that's our 200 status code response. I'm going to specify another one for 400 just to do some simple error handling. I'm going to include a quick description as usual and just say something like prediction failed, I guess. Hopefully that never happens. The next thing we need is also the schema. And of course, there's also going to be an object. And as for some properties, I guess we can just return a response, an error message. So I'm going to include this under the message field. And this message is going to be a string. And as an example, this is just going to say something like prediction failed sad face. And awesome. So yeah, that pretty much wraps up the swagger.yaml configuration file. So once we set everything up, we can actually run this on localhost before we deploy, and we'll go over it and see what it looks like. But before I move further, I actually realized I forgot a small detail, and it's basically where we can actually specify required fields. So if we want a predictions field in our response body to be required, we can specify that under a field called required, and we can just list that out. So I'm just going to write predictions here. So just make sure of that if you want your specification to be complete. Of course, you can also make it optional depending on the specification that you want for your API. So once that is done, we can actually go ahead and implement our spam classifier predict function. And as we specified earlier in our swagger.yaml file, we need to specify all of this or write this function under a file called spamclassifier.py. And now the first thing we want to do is, of course, import all the modules. So we're going to go ahead and import pickle because our model is stored as a pickle file, which I actually should have mentioned earlier. But if you recall from my previous video where we actually trained this model, we exported these two files as pickle files. So we're going to import pickle. We're also going to import pandas for data manipulation, and we also need to import Flask, and we're going to import two things, and namely they're going to be request and JSONify. Awesome. Okay, and of course it's probably optimal in a production system to use an actual cache, but this is just going to be sort of like almost like a demo or just to get you started project. I'm just going to use a local cache here just to store our model and TF-IDF vectorizer so that we don't have to query it or basically read it every single time if it's already been read. But yeah, we're going to use local cache for now. Now we can actually get started on the predict function. So we're going to start by writing the signature, and then we're going to go ahead and actually check to see if the loaded version of the model is actually in the cache already, and or whether the TF-IDF vectorizer is in the cache. Of course, if it is not, then we want to perform the read. So to perform the read, we can just use Pickle's load function. So we can go ahead and try to open a file, open this file in the .model directory where we have stored it. Of course, the directory will be different depending on where you're going to store your model.pickle file. We're going to, of course, read in binary as, oops, sorry, I missed a parenthesis, as model file here. And we're going to store the red output as into the local cache as a field under loaded model. So we're going to call pickle.load, and we're going to pass in the model file as its first argument. And of course, we're going to do something really similar. So I'm just going to copy this. We're going to do something really similar with the TF-IDF vectorizer. So I'm just going to type that out, and this is going to be the TF-IDF vec file. Just do some copy and pasting here. Awesome. Okay, that looks good. And just space it out. Okay, awesome. And so once that is done, once we have pretty much read all the files, the model and the vectorizer that we need, we can go ahead and implement a try except statement. So I'm going to set that up first. And we're just going to catch general exceptions. And we're just going to print the exception when it comes and, I guess, return the 400 error under the message field as such. Okay, awesome. And so inside the try block, this is where we're actually going to perform the prediction and formatting of the request body. So to do that, we actually need to read the request first, and we can do that by assigning it into a variable called comments. And the way we're going to format it is a nested array where each comment will essentially take, will be inside its own array. And we're going to use we're going to read this all from request.json. This request object is from Flask. And awesome. So once that's constructed, we can just do a simple check as well to see if there's actually any comments to begin with. Of course, if there's no comments at all, then we can just set the output of predictions. Sorry, I can type here, predictions to an empty array. And if it is an empty array, we can also just have a general return statement, which returns the predictions array at the end. So I'm going to type that out, and this is going to be a success case, so it's going to be a 200 status code. And for the case that we actually do have comments, we want to construct a pandas data frame so that we can pass it into our model's predict function. So we're going to go ahead and construct this data frame by creating a new variable comments data frame, and we're going to call pandas data frame constructor, and we're going to pass in the comments array that we have constructed as a data field. And we also want to specify a columns field. This will essentially specify the types of columns that are associated with our data frame that we'll be creating. And we only need one column for this model. Of course, this section is only it's really dependent on the type of model you'll be using. In this case, because we're doing a spam classifier that was trained by passing in a TF-IDF vectorized set of training data, we have to follow this sort of format. And of course, the data set originally had a content column, so we're just going to keep it similar. But of course, if your model might be different, but this one is more specific to the previous video, so I'm just going to leave it as such. All right, so the next field that we wanted to create is the TF-IDF vectorized version of the comments. Again, this is more specific to a particular use case of spam classifying YouTube comments, or basically natural language processing of text data. So we're going to follow this method. Anyway, we're going to reference our TF-IDF vectorizer from the local cache. As such, and we're going to call the transform method, and not the fit and transform, just the transform, because we are not training anything, we're not fitting on any data at the moment. But yeah, as for the transform method, we only need to pass in one argument, which is the actual data frame, the column of the data frame, which is the content column. Awesome. And last but not least, we need to generate the predictions when we actually have comments to predict on. And we can, of course, reference the local cache again, and we can retrieve our loaded model. and we can call the predict function with an argument passed in, and that will be the comments, the TF-IDF vectorized version of the comments. And we, last but not least, we also want to convert this to a list away from a NumPy array, so that when we return it as a JSON object, inside a JSON object, it can all be parsed correctly. And yeah, that pretty much wraps up the implementation for this function, or basically the main function. Now we can go ahead and actually run it, start it up, and see if everything works together. So when we tried to start the server, I actually realized I made a mistake, and I think it's really important to include bugs like these in the video as well, because I think it's really helpful so that you can probably learn from my mistakes and hopefully not make them. But anyway, so the error we got was something that said like fail to validate one of schema properties, and basically we had a schema violation in terms of what we defined, and I realized it's what I actually tried to add right at the end, so my bad. Basically, this required field is in the wrong indent. It actually needs to be aligned with properties at the same level of properties. As this is also one downfall of using YAML. Everything relies heavily on indents, so it's a little bit tricky sometimes. But anyway, so once we save that, we can just clear the terminal there, and we can just run python server.py. Of course, this is also in our pipenv. You can use virtual env if you wish. So we're just going to let this run, and once that is active, it should be available on port 5000, and I have a browser window here ready to go. As you can see here, it says all our endpoints are online, which is the message that we have pre-configured. And to access Swagger UI, we just need to navigate to /API/UI. And so this will load, and I'm just going to zoom in here. Awesome. Okay, so as you can see here, we have one operation. This is the tag field that we have specified earlier, the spam underscore classifier, and we have one endpoint, it's post. And we click into it, all the necessary fields that we have, like the description, the summary, and whatnot, have been pre-filled for us because we have specified it earlier. But yeah, you can feel free to rewrite this to however you need. And as you can see here under the success case, we can look at the model. It tells us that the predictions is basically going to be an array of integers, and it tells you a message of what it actually is. Also, it provides an example value for us, and this is all specified directly from our Swagger configuration file. Of course, let's just test it as well. We've also done this in the beginning, but because we pretty much wrote this from scratch, I just want to test it to make sure everything works. And awesome, as you can see here, this gets predicted as spam, and I'm sure this should be considered spam nonetheless. And awesome, okay, so once this is done, now we can actually finally move on to deploying this to Heroku. So once you've navigated to Heroku and created an account, if you haven't already, you can actually begin to create a new app. I've already done so, and I've just named the YouTube comment classifier. And once you've created a new app, you can to the deploy tab, and we are faced with a bunch of options. So there's different options where you can deploy our application. You can either connect to your GitHub repository directly, or we can use the Heroku CLI, which is what we'll be using today. So basically, if we want to use a CLI, the first thing we have to type, we have to first install it, and then the first thing we type is Heroku login, and essentially this will allow the CLI to log into the currently logged in user on the browser. So once that is done, you can actually skip immediately right down to the last step, which is this command, which basically allows your local repository to be assigned to the remote Heroku repository for our application. So we're just going to copy that. We're going to go ahead and head over to our VS Code here. I'm just going to paste that command, and that should assign the remote repository. And awesome. Okay. And then one more step before we actually make the deployment. What we need to do is actually create a proc file. This is a special file for Heroku deployments, and we only need one line here. Basically, this is like the command that will allow our server or application to start. So this is going to be a web application, so we're going to type it or prefix it with web : and we're going to use Gunicorn or Gunicorn, which we have installed earlier. So Gunicorn and then server : app. And this is the only line we need. So we can just hit save, and all we need to do now is just pretty much stage it, commit it, and push it up to the Heroku's remote repository. And once that is pushed, the job will immediately be triggered. And the benefit of using pipenv here is that Heroku by default already supports pipenv. So as soon as it sees a pip file, it will install all the necessary modules that we have specified in our pip file, and it will start the web server immediately. So that's pretty awesome. But I'm just going to push it now and deploy, and we'll be back once that is done. So as you can see here, the build actually completed successfully, and this is just a simple output of the logs that we had from the deployment. And I realized I actually made a mistake here, which I'd like to point out. Basically, the first time I tried to deploy or push it to Heroku, I was pushing to master, but I realized I actually previously changed the branch to main. So just make sure you use the correct branch that you actually want to deploy to Heroku and set that as the correct remote URL that you want to push to. So yeah, I'm pushing to Heroku main, and yeah, so these are the logs. And if we just take a look here at our application, we can click Open App. As you can see here, endpoints are online. That's our default message. And we go ahead and head over to API/UI. Awesome. So we are faced again with the Swagger UI. So if we just want to test this once again and pass in some random comments, saying thanks for watching. Hopefully this is predicted as not spam. Actually, I don't really know. Anyway, okay, I guess it's predicted as spam. Funnily enough, I guess we'll just leave it as that. But yeah, awesome. So now you've pretty much learned how to deploy a basic machine learning model to Heroku using a Flask API. Of course, just because we're using Swagger UI doesn't mean that you can't use things like Postman or perhaps even programmatically make requests to this endpoint. Of course, all of that is like expected, so you can definitely do that. I just didn't want to demo that because Swagger UI is already a really convenient interface for doing that. But anyway, if you found this video helpful, please do consider hitting the like and subscribe button down below, as it really helps out the channel. But for now, I hope you're all staying happy and well out there, and as always, take care.